magnet and investigating magnet. Today we are going to be learning about magnet and how we can investigate magnet. You have probably seen and used magnet before, is it not? Yes. Look at the ones. I believe you've seen one or more of these magnet. Okay, we have magnet in a compass, we have magnet in the fridge, we have magnet in your toileters, and then we have magnet in your chairs ball. Is it not? Yes. Which of these magnets have you seen before? Where else have you seen magnets? What were they doing? Okay, there are also powerful magnets inside speakers and computer drives. Alright, what do you think make one magnet more powerful than the other? The speakers magnet, they help to convert electrical energy into mechanical energy, which now produces the sound that you are hearing. Are you hearing me? Yes, you should know that without the magnet inside the speaker, you will not hear that sound. Or speaker has magnet. Okay, although they are trying to devise other means, but it's hard. Even your hard drive, most old TV, they all use magnet. Magnet is a very powerful and useful device. Okay, why? Because it has a very powerful energy that when written with code, it converts a lot of data. Okay, that is why it is used as an hard drive or as a part in hard drive of computers. I believe you know what an hard drive is, not? Hard drive is the memory where we store information inside the computer. Okay, magnet come in different shapes and sizes. Okay, the most common shape used in school are your bar magnet and the U-shaped magnet, which you can see here. But you also get circular magnet. Okay, the flat sheet like fridge magnet are made from the magnetic powder mixed with plastic. You know, in ancient time, magnet was discovered through a material which we call lodestones. Okay, it is from this lodestones material or magnetite that you cannot grind it into powder, mix it with plastic so that it can have some energy on its own too. So when it comes close to any material that also have the same magnetic behavior, like your fridge, it will stick to it. You can see the letter sticking to that board, is it not? Yes, the reason why it's sticking is because the powder magnet that is mixed with it. Okay, that is why it's sticking to it. A magnet and an ordinary piece of metal are not the same. It is different. Why is it different? A magnet has energy. Alright, it has energy. We call it potential energy. But a material does not have energy. Alright, a material is just a material. If it must have energy, we must give it energy. Do you understand? A magnet also have that, it uses that energy to attract materials that it likes. Alright, but an ordinary metal material does not do that. Okay, for example, can you use your two pots to gum each other at home so that they will stick to each other? No, they cannot. But if you take a magnet to your pot, the magnet will attach itself to the pot, or it will draw the pot to itself. Is it not? Yes. So those are the difference between a magnet and an ordinary metal. Now look at this bar magnet. The two halves are painted north and south. Can you see it? Yes. The red part is painted north, the blue part is painted south. Okay. This is because magnets have two poles, a north pole and a south pole. The magnetic force exerted by a magnet is strongest at its pole. What do they mean? If I take a magnet now, it's not all the part of the magnet do not have the same power to attract. Okay, if I'm getting closer to the northern pole, where the north pole is on the magnet, it will be more attractive than if I'm moving away from it. The same thing, if I was getting to the southern pole, it will be more powerful than when it's moving away from the southern pole. Do you understand? Yes. I know you want to wonder, why do we call it north pole and south pole? Why not call it East Pole and West Pole. Okay, is a model. The reason why I call it North Pole and South Pole is because the Earth, as you know it, you know about gravity, is it not? Yes, or anything that goes up must surely come down. Beside gravity, there's what we call magnetic force. You see the sun gives energy to the Earth. Now the Earth, the inner part of the Earth has iron. This iron has magnetic property also. And then we have wind blowing. When these three elements combine together, they create what we call a magnetic force. Alright? Now a magnet here on Earth, such as your compass, if you now station it, it will now be attracted to that magnetic force on Earth here. Are you getting me now? So while we have magnetic force created by the sun, we also have magnetic force in the Earth. Now the magnetic force created in the sun was discovered to be very powerful in the northern hemisphere, which is around United States area, Canada precisely, okay? The Arctic region. Alright? They now discovered that the magnetic force is more powerful there. So they now said, because the magnetic force is powerful there, they now use that model to be naming magnets, a North Pole and a South Pole. So why the magnetic force is exhibited by the sun, which combine with wind and then the core of the Earth. The magnetic force on Earth here is on the other side attracted to the magnetic force which is created by what I just told you. Okay, so that is the reason why when you pick a magnet, the North Pole will now be attracted to the South Pole and the South Pole attracted to the North Pole. So that's why they now name it the North Pole and the South Pole of the magnet. Okay, now when a magnet sticks to a surface, it is because the magnet is exerting a pulling force on the surface. The pulling force works to attract the surface to the magnet and they stick together. I told you before that the magnet has what? Energy. Okay, this energy is what we call the pulling force. If this energy meets another object that the magnet likes, maybe that is attracted to a metal like iron for example, it will draw the steel to itself with that force or energy that it has. Alright, it is the same thing that happens here. This is your fridge. Okay, the object you are putting, or this is your toy litter board. Now the toy litter has a magnet and it's attracted to the board, which also has a magnet. Okay, the moment you put it, it will stick to it. Why? Because it attracts using a pulling force. Using a what? A pulling force. Okay, now look at these two young men. Mr. A is gold, while Mr. B is Joshua. Okay, what do you think they are doing? What is actually happening in this picture? I will tell you. Both of them are having two magnets. Okay, now Mr. A, which is gold, is having this magnet in such a way that the South Pole is actually facing the South Pole and the North Pole is also facing the North Pole. While Mr. B, which is Joshua, is holding a magnet in such a way that the South Pole is actually facing the North Pole. Okay, so when Mr. A put the two magnets together, the magnet refused to stick to each other. He was now using his own power to join them together, and he successfully used his power to join them together. Okay, on the other hand, when Mr. B took the North Pole and the South Pole to face each other, the magnet wanted to stick to each other, and then Mr. B used his own force to hold the magnet together so that they will not stick together. So eventually when Mr. B leaves the magnet, the two magnets will stick together. While when Mr. A leave the magnet, the two magnets will separate together. That is what the arrow is telling you. The arrow is telling you that me, I'm going my way for Mr. A. Mr. A, you see, I'm going my own way. This other one say I'm going my own way also. Why? Because they are having the same pole facing each other. South pole facing each other, north pole facing each other. So they will not attract each other. Okay? On the other hand, Mr. B is having the north pole facing the south pole. And then the south pole is saying, me, I'm coming to meet you, north pole. And the north pole is saying, I'm coming to meet you, south pole. Just allow this our Oga to leave me. If you leave me, I must meet you. Do you understand it now? Yes, I believe you understand it. Now, magnet exert forces on other magnets. Sometimes this is pulling force, okay? The two magnets will be what? Attracted to each other. Just like what we have in this Mr. B scenario now. When he leaves the magnet, two of them will join together. On the other hand, or at other times, this is a pushing force. The magnet will be repelled. Say the word repelled. Say it again, repelled. So it will be repelled by each other and we push apart from each other. So eventually when Mr. A finally leaves the magnet, they will push away from each other. Tell me, leave me alone, I'm going my way. Leave me alone, I'm going my way. Is it not? One will go right, the other will go left. Okay? When this happens now, what does this diagram suggest about the forces between magnets? You can see that was what Mr. A was doing. The first diagram here is what Mr. A was doing. You can see the south pole facing each other. And the third diagram is also showing what Mr. A was doing. The north pole facing each other. What will happen? They will separate apart. If you bring two magnets, I think you've done it before. Have you ever played with the magnet where you use one magnet to be pushing the other magnet? The other magnet will be going away, you'll be pushing it, you'll be going away, you'll be pushing it, you'll be going away. Have you played that play before? I believe you've done that before. Me, I did it when I was small, okay? What you're actually doing, you are pushing the south pole to face the south pole. Or you are pushing the north pole to face the north pole. They will never ever attract each other, is it not? Yes. But you now discover that sometimes the magnet will even turn itself, is it not? It will turn itself and then attract each other. When it turns itself like that, know that it is the north pole that has connected to the south pole, or it is the south pole that has connected to the north pole. So north pole, they will repel each other. South pole, they will repel each other. But north pole, south pole, they will attract each other. South pole, north pole, they will attract each other. Now, what is likely to happen if you turn the two magnets around so that the north of the top one was facing the south of the bottom one? And why? You already know, is it not? Yes. They will attract each other. Is it not? Yes. Now, what we are saying is opposite pole attract. Okay? We say that the opposite or unlike poles of a magnet attract each other, and the like poles repel each other. What do we mean by the unlike poles? North, south, south, north. What do we mean by the like poles? North, north, south, south. Okay? In other words, if the two north poles or the two south poles are joined towards each other, the force will be a pushing one, is it not? They will be pushing away from each other and the magnet will repel each other. Alright? So opposite pole attract, but like poles or same poles repel. Watch this short video to learn or to get a full understanding of what we are learning. Welcome back. I hope you now have understanding of what we have been saying from the beginning of this class. So you agree with me that magnet come in different shapes, as you have seen, the U shape, the circular shape, and then the bar magnet, is it not? But all magnets in nature have north pole and a south pole, is it not? Now what you must know is this, that a magnet have north pole and a south pole does not mean that you can separate them. You cannot separate the north pole from the south pole, okay? If I get a magnet and then it has a north pole and a south pole, and I cut the magnet into two, that magnet that I've cut into two, I've now have two bar magnets, because the new one that I cut into two also have a north pole and a south pole, okay? And the old one also have a north pole and a south pole. If I cut it again, to still have a north pole and a south pole. Do you understand? Yes, I believe you understand what I'm saying. Now, the forces exerted by a magnet is strongest at its pole. I've told you before. The more the magnet gets to the north pole, the more the magnet will be very attractive. Sometimes you can get two big magnets, north and south pole, and then you try to take them to join together. Sometimes they will be drawing your hand. They will be drawing your hand, as in you can't even stop them. If you put your hand in between that magnet and the two magnets stick together, it might even injure you. Why? Because of the force they are using to pull each other. That force will hit your hand, and then you might have a scratch on your hand, okay? It is still that force that this compass uses. That's why when you put a compass, because the compass is, the north pole of the compass is attracted to the south pole of the earth, immediately the compass will turn and turn and turn and turn and position itself on the north pole. It is from there you now begin to use to direct your, to know your direction, whether to move northeast or northwest. Is it not? Yes. You also know that when the like poles are facing each other, like poles, I mean the same poles are facing each other, maybe north or south, the magnet repel each other. And when the opposite poles, that is unlike poles, north south north, are facing each other, the magnet attract each other, is it not? Yes. That now brings us to the end of today's lesson, okay? I want you to do your assignment and prepare for your, meanwhile, you stay safe. I'll see you in the next class.